continue with part 2. How can we make ingestion scalable and fast with millions of posts and billions of likes? But ingestion that's happening, well, essentially here. So to make it more scalable and more reliable, we can essentially introduce some sort of queue. Let's say we would have still our lambda, but that the DB trigger wouldn't be triggering lambda straight away, but it would essentially create an event in our Kafka or SQS. Probably we would need to use Kafka for billions of likes. Let's say so we're gonna have our Kafka. Yeah, like we can't like directly put it in Kafka. We would need some sort of service, or could be also Lambda again. But now the benefit is that if that Lambda fails in the middle, that message won't be acknowledged as a message won't be acknowledged as processed. So we'll be able to essentially rerun it and process again. In that way, we don't lose messages. That's kind of like one way. We can, because again, we're talking about billions of likes. So for that, we could use more of a like streaming solution. So from AWS, there's a thing called Firehose. And that's kind of made to deal with billions of likes, and that's probably something more appropriate for that, especially for billions of likes. Yeah, so that'll be actually better for solution, I think. Firehose, I think it's called. And there's like several services of Firehose. First is like first takes care of like intercepting those events, and Firehose Kinesis Firehose, I think it's something which deals more with saving that to, for example, S3, and then from S3 we may want to like update our cache with that count of likes. You implemented cursor-based pagination and set limits on sorted keys. Okay, that's what we did before. Your solution doesn't clearly explain how would you handle the scale of billions of likes beyond mentioning Kafka and Firehose using a like approximation approach where you store approximation of likes in the index, such as power of tools, and have a second pass to pull up-to-date values before final sorting and returning to the user. This would significantly reduce write volume to your indexes. Okay, for example, instead of updating your index every time, a post receives a like, you could update it only when the count crosses certain threshold. This reduces write operations by orders of magnitude while maintaining reasonable accuracy for search rankings. During the final retrieval phase, you would fetch the exact counts only for the posts that made it through the initial filtering, ensuring accuracy is the final results presented to users. This approach is particularly important to discuss in interviews as it demonstrates the ability to make practical engineering trade-offs when dealing with files. Okay, so we would. What happened? Like, I don't know. It just changed on some. Okay, how can we optimize the storage requirements of the system? Okay, so when it comes to optimizing storage, one of the things which comes to mind is that probably older posts will be much less relevant. So still probably important to keep them somewhere. But we can have a policy where we save older posts from our main database, and let's say we save them in S3 after let's say AR. We're gonna save it in S3. Yeah, in that way we can still retrieve them if we really need them, but it will be just way cheaper. Yeah, we're gonna have some sort of like limits for our inverted index. It's called inverted index actually. I'm actually not sure what's happening. Why it stops at random? Yes, that will be inverted indexes. Yeah, I'm gonna have our S3. Yeah, for like service, pretty much the same. The amount of likes will just become huge at some point. So we can just move them to cheaper storage, and in that way save storage on database side. Yeah, for search search is using our custom Elasticsearch. So, but optimizations here we already explained. There's lots of optimizations which we can make around cache. So for the cache we can implement some sort of pruning strategy, like we can, for example, least recently used or least frequently used strategy. Then we'll be if we exceed a certain limit, we'll be removing the oldest item or the oldest item with the lowest frequency of use. Yeah, because we want to keep things which are accessed a lot. We want to cache them. Also for the post, as it was mentioned before, we can have some sort of CDN here. So that CDN content we store there, we also need to be on occasionally we'll need to be pruning older content. Yeah, our Firehouse will be saving there'll be actually Kinesis. Um, Kinesis, the stream of data in Kinesis will be processed by Kinesis data analysis, I think it's called, and then saved by Firehouse to S3, let's say. And then when it exceeds the threshold, we could update our index here. Okay. You provided a comprehensive approach to storage optimization of multiple strategies, including moving all the posts to S3, implementing cache eviction policies, LRU, LFU, and using inverted indexes with settlements. Your design effectively separates hot and cold data paths, keeping frequent access content in fast storage while moving older or less accessed data to cheaper storage options. You include optimizations like CDN usage, cursor-based pagination, pre-committed popular queries to reduce storage and processing requirements. Consider elaborating on retrieval process when users search for older posts that have been moved to S3, including any performance implications or potential optimizations. So that will be potentially slower or even way slower if we move our data to S3 Glacier. While you mentioned pruning content, it will be helpful to define more specific criteria for determining which indexes to prune beyond frequency of use, such as time-based threshold or access patterns. It's lagging a lot. Your cache eviction strategy using LRU is good, but consider explaining how would you determine optimal cache sizes and eviction threshold based on usage pattern and available resources. Okay, sample answer is that we can keep stats on how often keywords are searched periodically with an async batch job. We can move cold index, so we keep stats on how often keywords are used periodically with async batch job. We can move cold indexes, which are rarely accessed by both ingestion and queries, to blob storage like S3 and prune indexes that are never accessed. Our search service can query the hot indexes in memory, and if then there is no entry, go to the cold indexes. Since those queries are very rare, our clients should be able to tolerate the additional latency coming from blob storage. Okay. Yeah, I'm not sure why it's not loading. Let me close more things. Okay, I closed a lot of tabs. But it still seems to be lagging. Um, it looks like this one we haven't done. Uh, let's do it again. How to make ingestion scalable and fast with millions of posts and billions of likes. Okay, so essentially, as we explained before, because we're gonna have billions of events, and then we can use Kinesis. And Kinesis has those. There's like several services which do each part of data processing. So there's um, there's Kinesis stream, which so there's Kinesis stream, which will collect, which will keep store our events in that stream. There is Kinesis data analysis, Kinesis data analysis, and it will essentially process our data. So it will, for example, count those likes, and then we're going to have our Firehose. Firehose. And data analysis, it uses those popular frameworks like Spark to do it. And then, we can use Firehose to save it in S3. And when we're saving that in S3, then we can have S3 events, because then at some point we want to update our counts here. But the thing is that's very, very time consuming. So we can do it in many ways. Yeah, we can. One of the suggested ways was to only keep updated that at the thresholds. But then to know the threshold, we need to know how many count, what's the current count of that of likes under that particular post. So then we need to essentially fetch either from database or cache to fetch how many likes we have, and if it's with power of 2, then we can update that with our new count. So the power of 2, I mean, we're gonna update at those sort of thresholds, yeah, to 2, 2, 4, 8, 16, yeah, and maybe even power of 10, and so on. So then, yeah, if we exceed, let's say, 16, only then we update. But let's say if our new batch would would get us to 15, it would stay there just to limit writes operations. Because yeah, updating those indexes, then that's not gonna be that easy, because then the post may be in multiple under multiple keywords. Obviously, posts consist of multiple large amount of content in some cases. Yeah, so that's kind of good strategy to have some sort of thresholds, but the drawback of that is that um, the results are a bit less accurate. Okay, your streaming architecture weaknesses for high volume data processing is well designed for handling billions of likes. Threshold-based approach using powers of 2 is excellent optimization that significantly reduces write operations. You clearly articulated the trade-offs between accuracy and scalability in your design, showing good engineering judgment. Your complete data flow from ingestion through processing to storage demonstrates a comprehensive understanding of large-scale system. Okay, to limit the number of writes, we need to make to our search indexes like we need to make to our search indexes like events. We can limit calling the ingestion service to only process powers of 2. Ingestion service to only process. Okay. Our search indexes will have approximately correct ordering for posts. In our search service, when we retrieve the list of posts that match a given search query, we'll grab more than we expect to return, e.g. 40 when we need 20, then look up the actual like counts for those posts from the like cache. Okay, yeah, we'll then resort the final list before returning to users. Okay. Okay. You mentioned using power of 2 thresholds for updating like counts in your indexes. How would you handle the case where post suddenly goes viral and receives millions of likes in short time period? What potential issues arise with your threshold-based approach in this scenario? Yes, so potential issue is, I'm not sure why it's not increasing. Let me pause that video and see what's happening.